The reason PEMDAS is a problem is because it glosses over a lot of the fundamental mathematics that most of us are missing. We just learn this trick, and then for the rest of our lives we're tied to it. And if we don't remember the trick, or
somehow our dear Aunt Sally falls down the stairs,
just not fair. It's not fair for all this math knowledge to be locked behind some mnemonic device. The fundamental theorem of arithmetic is just the basis of mathematics really as a whole, especially when dealing with integers. If we have the number like 28, we can see that this is a product of prime numbers. And so what I'm doing here is what most of you recognize as a prime factorization, and I'm just breaking 28 down into the product of its prime numbers. So 2 times 2 times 7 is the number 28. 2 times 2 is just 2 squared, and 2 squared times 7 is 28. And so we can think of this kind of in a different context. Instead of thinking about PEMDAS, thinking that
I need to do the exponents first.
Exponents are repeated multiplication. So if you're doing multiplication, you're doing multiplication. Why would exponents come first? 2 to the second power is just 2 times 2. Just understand that. It's not this magic trick that you put a little number above the number and now all of a sudden it has this priority. It's 2 times 2, it's multiplication. It all has to get done at the same time. So now I really challenge people, instead of thinking like, oh, here's this string of numbers, I have to do this computation. I see multiplication and I start thinking, what number is this, right? Because the fundamental theorem of arithmetic says that this is a number and we're going to shift it in a positive direction on the number line by 2 integers, by 2 units. And so the idea here is that, oh, this number should look familiar, but let's just go through it. That 2 squared is actually 2 times 2, right? And then times 7 plus 2. And so now this string of numbers just kind of unfolds, and we're basically doing what we've seen in the last slide in reverse. Last time we had 28, and we wanted to get the prime factorization, so we kind of undid it. But here we have the prime factorization of 28, and so we're looking at that in a different context. And now we see that once we have the number 28, our number here was 28. That was our 2 times 2 times 7. That was our number. And what did we do to it? Well, we shifted it along the number line, positive 2 units. What do I really see is I see a number here. This is a number, and this is what's happening to that number. That's the fundamental theorem of arithmetic. These are just integers, they're nice numbers, this is what we see. Here we have our number 28 again, hidden here. This time we're going to look at minus 2 and then divides 2. It's important that every time we see divide, we have to remember that division is actually multiplication by that fraction, so by the inverse of that number. And so instead of divides by 2, this is times 1/2. And that's one of my big beefs with the PEMDAS, is that it's really taking away this idea that multiplication and division are inverse operations, and so is addition and subtraction. And so here we have our number on the left, which is 2 times 2 times 7, which is 28, and a number on the right, which is 1. And now we can see that, hey, wait a second, subtraction isn't this fancy thing. It's actually just the addition of negative numbers. Subtraction is the addition of negative numbers. Division is the multiplication of the inverse of the number. And so now we can really see that the E
and the D
and the S, all in PEMDAS, are redundant. And it's because of our field axioms. Addition and its inverse. So addition is, add, and the inverse is really just adding a negative number. That's all it is. Multiplication, I like to think of it as dot. The multiplication is the inverse of the number. Or how we see this in most math classes around the world is it's going to be multiplication of 1 over the number. That's what it is. So like we had divide by 2. Well, the inverse would be 1 over whatever that number was, and we saw that was 1 over 2, or just 1/2. And that brings us to parentheses, and parentheses stand for priority. They show priority. So it means that these things get done first. Whenever we're looking at a string of numbers, we're looking for the numbers being defined through multiplication, as numbers are, multiplication
Specifically
through primes. But parentheses show us what to do first. They show us, they guide us the way. They are our light. And oftentimes, parentheses will show priority in the addition-subtraction field, in the addition and additions inverse, which is what we see here. And what does this do? Well, this turns our 7 minus 2, that turns it into a 5, and our 2 squared is just 2 times 2, and our divides by 2 is just 1 over that number, which is 1/2. And so we have 20 times 1/2, and it's 10. So really my final thoughts on the PEMDAS is that it's redundant and it's just so played. Parentheses are priority, so those things have to come first. But as we saw, exponents are multiplication, multiplication is multiplication, and division is multiplication. And further, addition is addition, of course, and subtraction is also addition. It's just addition of negative numbers. And so to have all these different letters and dear Sallies in here is too much. It's too much to handle. It's too hot to hold. Get it out. Get it out the kitchen. So as always, if you like this video and you learned something, hit that like button down below. And don't forget to subscribe for new content. Thanks for watching, guys. I'm out.